make all the difference. All right, you're going to be presenting to us on your rock launcher work. Whenever you're ready, go ahead and I'll start the timer.
Thank you, Shanti. Hello, everyone, and thank you for this opportunity. Today, I'm going to talk about the robot that we built in the University of Saskatchewan. But first, let's talk about what's this robot will do and the background of this robot. Um, if you know curling, the curling stone is famous for its unusual behavior. I said unusual because if you grab a glass of water, you just spin it and throw it down the table, you will see it will deviate to one side. And its deviation depends on the rotation direction. So, for example, if it's rotating clockwise, it will deviate to the left side. However, in curling stone, while the curling stone is going down the ice and it's spinning clockwise, it will deviate to the right side. For a century, scientists tried to explain this behavior, and up to now, none of them can explain it quantitatively or qualitatively. And there is a gap there. What's the gap? Is the control of the variables of the research. For example, the velocity of the stone, they couldn't control it as well that this robot can do. So we designed this robot to control the linear rotational velocity of the curling stone and launch it down the ice at the preset angle to the long axis of the ice sheet. Like every robot, it has three phases: designing, prototyping, and testing. In the designing phase, we define and determine the criteria like the objectives and constraints. In the prototype, we built a prototype for this robot and we put it in the test phase. And we have some feedback from the prototype, and this will iterate in this cycle. And we do some modification with designing and do it again and again. Meanwhile, in the testing, we have some experiments results, which is really interesting for us. And for example, researchers believe that the rotational motion of the stone caused this curl, but we found that in a specific range of linear rotational speed of the curling stone, the stone rotational motion has no significant effect on the stone's trajectory. Thank you very much.
Wonderful. Thank you, Amir. Curling is definitely a hot topic right now, considering the Scotties is on. So that's really cool research. Well done.
Thank
All
you.
right, we're going to